Hello everyone, I am Zhang Qiyuan, today's lecture teacher. Today, we continue to study the second task of Project 2 Weight and Balance of Aircraft. In the Aircraft Construction Course, Maze Aircraft Weighing Method and Balance Control. This part of the content will introduce in detail the specific operation process of aircraft weighing, balancing calculation methods, and measures to deal with extreme situations, etc., which is very practical. I hope everyone will listen carefully. Our mission mainly covers 5 aspects: weighing preparation, weighing measurement, balance calculation, extreme conditions of weight and balance, and use of ballast. Next, we will learn one by one in this order. First, let's move on to part 1, weight preparation. As the saying goes, if a worker wants to do a good job, he must first sharpen his tools. Making full preparations is the prerequisite for ensuring accurate weighing of the aircraft. In this part, we will understand from 2 aspects: the preparation of the aircraft itself and the preparation of the weighing equipment. Preparations before weighing the aircraft and preparations that need to be done before weighing the aircraft mainly have the following points. Keep the aircraft in a horizontal altitude, which is the basis for ensuring accurate weighing. Wash the aircraft. When an aircraft is ready to weigh, it should be cleaned, and all dust and impurities should be cleaned from its surface and its interior. Check the list of aircraft equipment to ensure that all required equipment is installed, and remove all items not included in the list. Drain the fuel system until the fuel quantity is indicated as 0, leaving only remaining fuel that cannot flow out. It is full of hydraulic oil tanks and slide tanks, and hydraulic oil and lubricating oil are part of the empty weight. Drinking and washing tanks and toilets should be emptied. Pay attention to the position of each component of the aircraft, such as the spoiler, leading edge slats, flaps, and helicopter rotor system, etc. Ensure that all facilities included in the approved empty weight are installed in the correct position. Remove things that are not carried in the regular flight, and check the luggage compartment. Make sure it is empty. Put all inspection covers, fuel tank covers, doors, and other components back in place, and the doors and sliding canopies are in the normal flight position. Preparation of weighing equipment. The preparation of weighing equipment is also important. These equipment need to be prepared: scales, hanging equipment, jacks, and horizontal overhead equipment where the scales are used to measure weight. Hanging and jacks are used to lift or support the aircraft. Horizontal overhead equipment is used to keep the aircraft at level. Wheel chocks and sandbags, which function to keep the aircraft stably parked on the scale. Scale, bubble level, vertical, white powder line, and measuring tape. These are used to measure the level and the distance from the focus to the reference surface. Applicable aircraft technical specifications and weight and balance calculation tables provide a basis for weighing and calculation. If possible, the aircraft should be weighed in a confined building where no air flows to cause errors in the scale reading. Weighing outdoors is also permissible if the wind is small and the humidity in the atmosphere is small. Weighing equipment. Different types of aircraft apply to different weighing equipment. Scales are usually used in smaller aircraft. Electronic scales are often used to weigh large aircraft, which are generally weighed by load sensors placed between jacks and bases. Finish the preparations, and next we'll go to the second part, weighing measurements. This part mainly introduces the specific procedures of weighing measurement, which is a key link in obtaining accurate weight data. The measurement procedure mainly includes the following steps. Place the aircraft on the scale and adjust to a horizontal state from the reference surface, the main focus, and the tail or front wheel. The focus is suspended vertically, allowing the vertical to contact the ground. Use chalk to mark the ground at the vertical contact point, and also use white chalk to connect the marks to form a clear relationship between the weighing point distance and the reference surface. When the aircraft is horizontal, the weight indicated on each scale is recorded. After recording the weight and measurements, remove the aircraft from the scale and weigh the gross weight. Finally, gross weight is subtracted from each weight scale reading containing gross weight to obtain actual weight data for the aircraft. After obtaining the data of the weighing measurement, you will enter the third part, equilibrium calculation. This part will learn how to calculate the center of gravity of the aircraft based on the measurement data, which is the core content of weight and balance control. The basic formula for center of gravity calculation is the center of gravity of an empty aircraft equal to total moment or equal to total weight. It should be noted here that the total moment is the algebraic sum of the key moments, and the moment of temporary weight, such as fuel, is deducted. In terms of data processing, it is said that the key force arm should take positive and negative values according to the position of the reference plane, and the moment symbol should be determined by the increase and decrease of weight and its position, and the center of gravity should be accurately calculated in this way. After mastering the equilibrium calculation method, let's learn the extreme situation of the fourth part, weight and balance. This part will help us understand the hazards of the aircraft's center of gravity beyond the limit and related verification methods. The so-called extreme situation of weight and balance refers to two situations when the position of the center of gravity of the aircraft is at the front limit and at the rear limit. The aircraft has two fixed limit points, front and rear. We need to check whether the position of the center of gravity of the aircraft exceeds these two limit points when loading cargo, because at any time in flight, the center of gravity of the aircraft is not allowed to exceed these 2 points. Otherwise, the stability of the aircraft will become poor and the control will become difficult. It is necessary to check the weight and balance in the following situations. When the center of gravity of the empty machine falls on or outside the edge of the allowable range specified by the center of gravity of the empty machine, or when it is not loaded according to the loading scheme stipulated in the aircraft type certificate. Extreme situation check calculation. Extreme situation check calculation is divided into front limit check calculation and rear limit check calculation. Front limit check calculation needs to master the weight, force, arm, and moment of the empty machine, and the maximum weight of each useful load item before the front limit of the center of gravity, force, arm, and moment, and minimum relevant data after the front limit. The rear limit check calculation needs to understand the empty machine data, the maximum weight, arm, and moment of each useful load item after the rear limit of the center of gravity, and the minimum relevant data before the rear limit. What should we do when the center of gravity of the aircraft is not within the limit? Next, learn the fifth part of the study, the use of ballast. Definition of ballast: weights used on an aircraft to achieve the required center of gravity balance when the aircraft's center of gravity is not within the limit or at the operator's desired position. Usually, it will be placed at the rear or front as far as possible so that the center of gravity can be within the specified range with the minimum weight used. Ballast is divided into permanent ballast and temporary ballast. The permanent ballast is used to compensate for the movement or installation of the equipment and will stay on the aircraft for a long time. It is usually a lead bar or lead plate bolted to the aircraft structure, which may be painted red and pasted with a notice of permanent ballast, non-removable. It is important to note that installing permanent ballast increases the aircraft's unloaded weight, reducing useful loads. Temporary ballast, also known as movable ballast, is used to meet certain load conditions, and each use may be different. It usually takes the form of a lead bullet bag, sandbag, or other non-permanently installed weight, which should be marked ballast weighs XX kg or XXLB, and determines whether it needs to be removed based on weight and balance checks. Baggage compartments are usually the most convenient place to place temporary ballast. The above is the whole content of this aircraft weighing method and balance control course. Thank you all for watching. We will see you next time in class. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?